Hi everyone, I'm Joan Monteroso, 5 BS Chemistry with Material Science and Engineering, and I will be presenting my topic entitled Tiny Biobots Powered by Heart Cells Can Swim Like Sperm. Researchers from the University of Illinois fabricated a biobot, or a biohybrid swimmer, that can propel itself on fluids with a viscosity resembling that of the body fluids. We call it a biohybrid swimmer since the microstructure is composed of a flexible polymer filament, more specifically polydimethylsiloxane as the base material, and heart cells and fibroblasts, which are responsible for the movement of the biobot. The fibronectin coating aids in the adhesion of the heart cells on the selected sites of the structure. The motion is produced via the wave propagation created by the contraction of the cells, which self-align in a few moments after being seeded onto the filament. The design of the biobot was copied from the structures of flagellated creatures, such as the sperm. The movement speed, however, of the biobot is quite slower than that of the sperm. So why does this technology have a potential to be a big deal? It is because it can have various applications in the fields of medicine and environment. The long-term goal behind the fabrication of the biobots is to be able to create complex machines that can sense light, chemicals, and can also navigate toward the target. As biosensors, the medical applications of biobots include the subfields of optogenetics, wherein the light is used to control light-sensitized neurons, cancer treatment, targeted drug delivery systems, and also minimally invasive surgery. As we can see, there are so many potential applications for the biobots. The research simply tells us that it is very possible to create tiny biological machines. This huge step in development opens up a lot of possibilities in the field of biosensors. Further research regarding the functionalization of the self-propelling biohybrid swimmers will eventually lead to commercialization. The biobots can also be mass-produced, and the heart cells can be replaced by other kinds of muscle cells to make way for light-sensitive or temperature-sensitive swimmers. In the Philippines, but also throughout the world, the search for the cure of cancer is still ongoing. The biobots may be the key in implementing highly target-specific cancer treatments. Biobots can be directed onto specific cancer sites and provide treatment without harming the healthy cells of the body. Perhaps, pursuing this idea for cancer treatment can be highly rewarding. A related patent to our biobot is that of the magnetic nanostructured propellers, or MAPs. These are also microstructures that propel at a low Reynolds number. The main difference, however, is that its navigation is controlled by an external magnetic field. The obvious disadvantage of these microstructures is that it is driven by an external magnet and does not propel itself, and hence it cannot be sensitive to its own fluidic environment. Self-propelling swimmers, on the other hand, can be modified to make it sensitive to its immediate environment, which is primarily the goal of an effective drug delivery system. And that ends my report. Thank you for listening.